Okay, so anytime we have two fractions and we are trying to add or subtract those, we have to have a common denominator. So that's going to be our first step here, and this is a very common step in this entire chapter, is to get a common denominator. The easiest way to go about getting a common denominator is to multiply by the opposite denominator. And what I mean by this, the fraction on the left, the denominator is 1 minus sine theta. So I'm going to multiply this one, top and bottom, by 1 minus sine theta. The fraction on the right, the denominator is 1 plus sine theta, so I'm going to multiply this top and bottom by 1 plus sine theta. And the reason that we can do this, if I look at this 1 plus sine theta side, 1 plus sine theta over 1 plus sine theta, the numerator and the denominator are the same, so that means that fraction is equal to 1. So essentially we're just multiplying by 1, but that's the technique that we're going to use to get a common denominator, because now if I look at my denominator, I have 1 plus sine theta times 1 minus sine theta, and I have 1 plus sine theta times 1 minus sine theta. So now I can confirm that I do have a common denominator, and I can just simply add. So I'm going to do a little bit before I add those. I'm going to actually fold out the bottom. And sometimes we do need to fold out, sometimes we don't fold out the bottom, but when I do, 1 times 1 gives me, I'm going to come way down here, 1 times negative sine is negative sine theta. Sine theta times 1 is sine theta. And sine theta times negative sine theta is negative sine squared theta. The denominator on the other side, since we've already confirmed that they were the same thing, I'm just going to rewrite it without going through all the steps. And now up top, I would distribute the 1, which isn't going to change anything, so it kind of seems pointless there. And the same thing, distribute the 1 here. And now I bring down that plus sign. And now that I have a common denominator, I can actually add those. But I'm going to do one more thing before I add. I see I have a negative and a positive sine theta, so that's going to cancel out. So my denominator now is just 1 minus sine squared theta in both of those. So I'm going to combine those to one fraction. And I'm going to add. So on the left-hand side, I have 1 plus sine theta. And now I finally get to add plus 1 minus sine theta. And if I simplify the top, I have a positive and a negative sine theta, so those cancel. And then I have a 1 plus 1, so that gives me 2. So I have 2 over 1 minus sine squared theta. Anytime that you see a 1 and a trig function squared, you should think Pythagorean identity. 1 minus sine squared theta is going to give you cosine. So think back to sine squared theta plus cosine squared theta equals 1. If I move the sine squared theta over, that gives me cosine squared theta. It's equal to 1 minus sine squared theta. This is exactly what we see here. So this is equal to cosine. So I have 2 over cosine. I'm sorry, I ran out of room. I'm going to come over here. 2 over cosine squared theta. That's where I'm at. And then we have this identity that says 1 over cosine theta is equal to secant theta. So in this case, this is the same thing as 2 times 1 over cosine squared theta. So the 2 is going to remain, but the 1 over cosine squared theta is going to turn into secant squared theta due to this rule right here, and that's going to be my answer. 2 secant squared theta. So even though you had answered this one, we're going to ignore that one. And the correct solution should be 2 secant squared theta.